PQRS is a parallelogram with diagonals intersecting at point O. Name two pairs of congruent triangles in the above diagram. Triangles OQR and POS are congruent. So let's see why. So here's OQR and here's POS. These two triangles are congruent. Well, these two angles are the same in both triangles because these are opposite angles. We also have that this angle here is equal to this angle here. These are a pair of alternate or Z angles because QR is parallel to PS, and we also have that the remaining angles are the same. Well, the three angles add up to 180 degrees, so if two angles are the same in two triangles, then the third angle is automatically the same. Also, we can see that these are a pair of Z angles. So the two triangles are similar. Also, we have one side the same in both triangles. The side that's the same in both triangles is actually this side here and this side here, because opposite sides of a parallelogram are equal in length. So if we have just one side the same and two angles the same, then by angle side angle, that's abbreviated ASA, which means one side the same in both and two angles the same in both triangles. The two triangles are congruent. Actually, there are other sides that are the same. The diagonals of a parallelogram bisect each other so that this distance here equals this distance here, and this distance from P to the intersection point of the diagonals equals this distance here. So that's the reason why these two triangles are congruent. Now another pair of triangles is POQ and SOR. So we can prove that these two triangles are congruent in exactly the same way. Prove that triangles POQ and POS are equal in area. So here are the two triangles. Well, since the diagonals of a parallelogram bisect each other, we see that the distance of Q to O is equal to the distance of O to S. So both triangles have a side in common. Not only that, if we're calculating the area of, say, POQ using this side as base, then the perpendicular height is the distance of P down to the base. I call this distance H. So the area of POQ would be half the base QO times the height H. But you see that the area of this triangle will be the same as the area of this triangle if we take OS as the base of the second triangle. It's got the same base as the base of this triangle, and it's also got the same height. To get the perpendicular height of triangle POS, we just drop down this perpendicular. We would have to extend the base to meet this perpendicular, but both triangles have the same perpendicular height. So taking these sides as base in both triangles and H is the height of both triangles, the area of both of them is the same. So to write this down, you could say that the diagonals bisect each other, that is, the diagonals of a parallelogram bisect each other, and so you could indicate the two equal sides of these two triangles. So QO equals OS. Then you could indicate the perpendicular height of both triangles. So the area of triangle POQ is half its base, taking QO as base, times the height H, and the area of triangle POS is a half of OS times H. But since QO is equal to OS, we see that the areas are the same. So these values will be the same. See, that happens when one side of two triangles lie on a line, on a straight line. And then if these bases are the same, also if the third corner of the triangle is the same in both triangles. That's what happens here. Prove that all triangles with O as one vertex are equal in area. So there are four triangles that have O as one vertex. The vertex of a triangle is just a corner of a triangle. So here they are. Okay, well, we proved earlier, or in the answer to part 1, that triangle POS is congruent to triangle OQR. This triangle is congruent to this triangle here. If two triangles are congruent, they're equal in every way. In particular, the areas of the two triangles are the same. So the area of this triangle here is equal to the area of this triangle here. But of course we know that the area of this triangle is equal to the area of this triangle. So that means that all three areas are the same. Now what about this triangle here? Well, from part 1 we saw that this triangle here is congruent to this triangle here. So the area of triangle POQ is equal to the area of triangle SOR. So the area of the four triangles is the same.